Hello everyone. In this part 2 of linear programming, we will discuss about the mathematical formulation of LPP and solution of LPP with bounded feasible region. So let's start with the question, and from question only we will understand how we have to form the tabular form to solve the problem, and from tabular form how will we get the constraints. So in question number 1, a company manufactures two types of cardigans, type A and type B. It costs rupees 360 to make type A cardigan and rupees 120 to make a type B cardigan. The company can make at most 300 cardigans and spend at most rupees 72,000 a day. The number of cardigans of type B cannot exceed the number of cardigans of type A by more than 200. The company make a profit of rupees 100 for each cardigan of type A and rupees 50 for each cardigan of type B. Formulate this as a linear programming problem to maximize the profit of the company, solve it graphically and find maximum profit. So from this we are observing we have two types of cardigans, cardigan A and cardigan B. So let the number of cardigans of type A is equals to X and the number of cardigans of type B is equals to Y. And side by side we will also consider the total profit is rupees Z, because what they are saying, we have to find out the maximum profit of the company. So here the profit, whatever function we are going to form, that is known as the objective function. So what is this? What we are observing, we have profit of rupees 100 for each cardigan of type A. It means total profit for cardigan of type B is 100x, and rupees 50 for each cardigan of type B. It means total profit for cardigans of type B is 50y. So this is profit for this 100x and cardigan this, what is this, 50y, and what we have the requirement, we have to maximize this thing. So we have to maximize. Now what they are saying, the company can make a at most 300 cardigans. It means number of cardigans of A, X, B, Y, and what is the requirement? At most 300. What is this? At most 300. And they are saying the cost rupees 360 to make a cardigan of type A. It means this become 360x, this become cost 360x, and for B it cost rupees 120. It means this become 120y, and the profit is at most rupees 72,000. So this is 72,000. Now another condition is the number of cardigans of type B. It means this is type B, means Y cannot exceed the number of cardigans of type A by more than 200. It means this is the production of cardigan of type B, that is Y, cannot exceed the number of cardigans of type A by more than 200. It means what is the meaning of this? At most X plus 200. This is the part. Now from this what we are finding, we have Z is equals to 100x plus 50y. This is the objective function, and the constraints are, what are the constraints? This will be X plus Y at most 300. It means less than and equals to 300. This is the first part. And 360x plus 120y at most 72,000. It means less than and equals to 72,000. This is the second equation. And another is y less than and equals to x plus 200. It means y minus x less than and equals to 200. This is the third equation. And the non-negativity of the variables. It means x greater than and equals to 0 and y greater than and equals to 0. Like the previous explanation, we have to first of all represent it graphically, and after giving the graphically representation, we will find out the corner points, and from corner points we will find out the maximum profit. So let's see how will we draw the graph of this part. Now we consider the following equations. First is x plus y is equals to 300. It means if x0 y 300, if y0 x 300, by the origin test 0 less than and equals to 300, it means this is true. Now for this second part, we have 360x plus 120y is equals to 72,000. If x0 y 600, if y0 x 200, by origin test 0 less than and equals to 72,000, this is also true. Now another is y minus x is equals to 200 we will take. If y0, if x0 y 200, and because we are not going to the negative portion, so we will take if x 100 y 300. Now by origin test 0 less than and equals to 200, this portion is also true. Now we will draw the first of all graph from these all informations. So look at this thing, what graph will come. So this is the graph for this part, and from this graph what we are observing, we have the O, P, Q, R, S are the corner points, and in between this is the feasible region. Now for this corner points we will find out the value of Z. Now the corner points P 0 200, Q 50 250, R 150 150, S 200 0, O 0 0. So once we will put the values here, so this is become for P 10,000, for Q 17,500, for R 22,500, and for S 20,000. For O it is 0 only. So what is the maximum? This part only. So we can say 22,500 is the maximum value of Z in feasible region at x is equals to 150 and y is equals to 150. It means the number of cardigans of type A is also required for 150, and the number of cardigans of type B, the number of this one is also 150. So in this way we have to solve this problem. Very important portion. With the question number 2, an aeroplane can carry a maximum of 200 passengers. A profit of rupees 1000 is made on each first class ticket, and a profit of rupees 600 is made on each economy class ticket. The airline reserves at least 20 seats of first class. However, at least 4 times as many passengers prefer to travel by economy class as by first class. Determine how many tickets of each type must be sold in order to maximize the profit of the airline. What is the maximum profit? Formulate the above LPP mathematically and solve it graphically. For this, let number of first class tickets is equals to x and the number of economy class ticket is equals to y. Total profit rupees z. First of all, we will make the tabular form. In tabular form, first class ticket, economy class ticket, and the requirement. Now, first case profit 1000 for first class ticket on each, 600 for economy class ticket for each. It means this become 1000x, 600y, and we have to maximize this thing. Now, this is also given. Aeroplane can carry a maximum of 200 passengers. So passengers x, y, at most 200. After then the airline reserve at least 20 seats of first class. So first class passengers x, this is at least 20. However, at least 4 times as many as passengers prefer to travel by economy class as by the first class. It means economy class passenger y. What is the condition? At least 4x. Using this, we have the objective function z is equals to 1000x plus 600y, which we have to maximize. Constants are x plus y less than and equals to 200, y greater than and equals to 4x, x less than and equals to, x greater than and equals to 20 because it is at least, and x greater than and equals to 0, y greater than and equals to 0 because non-negative variables. Now we will draw the graph for this. For this we will take x plus y is equals to 200. These are the points. Origin test we will do, it will come true. For this y is equals to 4x. If x0, y0, if x40, y160. Line is this, so we can't apply the origin test. That's why we are taking the point 40 0 and we are observing this is the false. It means this side only. Now another is x is equals to 20. By origin test it is also false. Using all this, we are observing this is the feasible region having the corner point ABC, the point A 20,180. Find the value of Z. Using this it will come 1,28,000. B 40,160, 1,36,000. C 20,180, it will come 68,000. What is the maximum? 1,36,000. So we can say that maximum profit is 1,36,000 at X is equals to 40 and Y is equals to 160. Therefore, airline reserve first class ticket, number of this 40 and the economy class ticket 160. So this is the way to solve this problem. On the basis of this, do the practice for other questions. Thanks and God bless you.